Okay, so I want to continue with some graphing calculator videos just to help you if you need it. I know some of you have a lot more experience with the graphing calculator than others, so hopefully this will help those of you who do need it. So first thing I want to make sure you understand is that you may have a couple of different kinds of versions of software on your calculator. So you may either have that new operating system or that old operating system, depending on whether you have a TI-83 or you have a TI-84, 84 plus. You may have a little different software. And some of you may have a TI-84, the CE edition. Those have the newer software as well. So there's some different versions of the TI calculators out there. And it's just different in terms of how it looks when you type something in. So for example, let me show you with my calculator here. This is a TI-84 Plus CE, but it works just like a TI-84 Plus does. So in this situation, if I wanted to, there's two different modes I could be in. So if I click on mode here, then some of you are going to have this math print and or classic. So math print to me is a lot nicer in some ways because it allows you to type it in just like you would see it in a problem or something. So if you have the math print, I would encourage you to use that when you're typing in a function and you're going to graph, which we're going to look at in a few minutes here, because it should look exactly like it looks on paper or on the problem you're viewing on the screen. It'll look identical in math print. If you have classic, it's going to look a little different and it's going to force you to sometimes have to use parentheses and different things. So you have to be a little bit more careful if you're looking at something in classic versus math print. So right now I'm in math print. So let's get out of this. Let's do second and quit to get out of that. So for example, let me just show you with a very basic example here. If I did 8 and I raised it to the second power, with this math print, it's going to actually put it as an exponent. Now, if you want to get out of the exponent, this is the one frustrating thing about the math print. You do have to move that arrow over. If you don't, you're going to continue to type up here in your exponent where maybe you didn't want to. So that's the nice thing about the math print is it looks exactly like it would look on paper. And you know that 8 raised to the second power is 64. If you are in the other mode, or if your calculator actually has that older operating system, which is your classic system, then if you come over here and you highlight classic by hitting enter, and then go back to your blank screen, now if you type in 8 raised to the second power, it's going to look a little bit different. And if you're in this mode, if you're doing 8 raised to something, this is where you're really going to have to be careful and make sure you use parentheses. And it works the same way for a fraction. The fraction will look a little bit different depending on the mode you're in. So just be careful about the two modes that you have on your calculator. You get the same answer either way. I would encourage you, if you have that math print, to go ahead and put it in the math print and leave it in that math print. Just be real careful about your cursor and where it's located. If you have just the classic, if you have an 84 and it doesn't have this math print, you can actually update it to that newer operating system. You would just have to link it to a calculator that has that newer operating system. And I can help you with that if you need help with that, and some of your classmates may be able to help you with that as well. So just be careful about those two modes. So I'm going to work these problems that we're going to be graphing in math print, and we'll go from there. All right, so I want to talk through how you graph on your calculator and just point out a few things. Again, like I said, some of you may not need this video at all. Others of you, you're starting from scratch with a graphing calculator. You're going to need this plus maybe some more tutorials to help you with that. So y'all have varying degrees of background and experience with the graphing calculator. So I want to look at graphing a few problems. So let me skip down a few slides in my notes here and look at some graphing. So we're going to find the domain and range, but as we find the domain and range of these functions, I'm going to talk through some things with the calculator. So let's look at this first one here, which is f of x, or y, equal to 2x to the third minus 4x squared plus 5x minus 3. And so that's the function that we're going to type into our calculator. So to get to the graphing, you want to get to what you see over here on my fancy software, which is that y equals, which across the top are your buttons that you would use if you want to graph anything on your calculator. So I'm going to go to the y equals, And first and foremost, if you have anything in here and you want to get rid of it, you can hit the clear button and that will get rid of a line for you. So you see you have y sub 1, y sub 2. These are all your like f of x, g of x, h of x. These are my different functions. So I can only type something in if it's solved for y. That's the only way I can type something into my graphing calculator is if it's already solved for y, which luckily for us, a lot of what we do in this class are functions, and so they will be solved for y, or we could easily solve them for y to be able to graph them into our calculator. So we have our function there. We want to type in 2x raised to the third minus 4x squared plus 5x minus 3. So I'm going to type it in just like I see it there. So 2 times, and then here's my button for my variable. So 2 times, depending on the mode that I'm in, it should come up as x for you. So 2 times x raised to the third power. So you notice that it made it an exponent, since I'm using that math print version of this, and I want to get out of my exponent, so I want to move it over to get that cursor big again. So 2x to the third minus 4x squared, so minus 4 times x raised to the second power. So you can either hit raised to the second, or there is a button that squares things because it's a popular button. So minus 4x squared, and that'll go ahead and square it for you. And then plus 5x and minus 3. So plus 5 times x, and so you don't have to put the time symbol in there. When you type 5x or 4x squared or 2x to the third, it knows that means multiplication. So plus 5x and then minus 3. So there's my y1. There's a couple of times in this class where you're going to have a y1 and a y2 when we start looking at the intersect method, but for now you should just have a y1. You won't need other functions that you're graphing at the same time. So one of the common things that may happen to you is when you go to hit graph, you might get an error message if you're just on this window and first picking up your calculator. So make sure that when you go to graph that none of these plots up here are highlighted, because you may have accidentally turned one on, or if you took a statistics class, these may be highlighted. So if you want to get rid of any of those being highlighted, then you hit enter. So enter will highlight it. So if you ever come up to this y equals screen and you see this plot highlighted or blacked in around it, then you want to make sure you unhighlight that. So you would go up to the top there and I would hit enter. Excuse me. I would hit enter and that would unhighlight it for me. So there's my y equal to 2x to the third minus 4x squared plus 5x and then minus 3. So you can see over here you have the 3 different views that you can look at something on your calculator here. So you have what the screen I'm on right now, which I'll update in just a second. So y1 equal to my function there. When I go hit graph, then I'm going to get this appear, and we'll talk about our window and different things a little bit more. And as you saw in some previous videos that you watched, you have your table and how your table is set up and stuff. So let's hit graph. And I may not be in a standard window, but if I'm not, we'll get it into a standard window. So there is my function, y equal to 2x to the third. Let me update this over here. So y equal to 2x to the third minus 4x squared plus 5x minus 3. And now I'm getting a shape of this graph. Now, some of you, when you hit graph, you may not have seen the exact same window that I see here. So normally where you want to start anything is in a standard window. So the easiest way to get to a standard window, if you have something that's not already in a standard window, is across the top here you have this button that says zoom. And just like you could on a camera or anything, you can zoom in, you can zoom out. So you can zoom in, zoom out, and some different things that we won't use. But this one down here, number 6, where it says zoom standard, that is the one that will get it back to a standard viewing window for you. So if you are in a standard viewing window, then every one of these tick marks represents 1 unit. And I go -10 to +10 with my x-axis, or my horizontal axis, and then -10 to +10 with my y-axis, or my vertical axis. That's if I'm looking at something in a standard window. Now, everything does not fit naturally when you graph it into a standard window. So you may at times have to do some adjusting. Or when you're looking at a problem in your homework or on a quiz or something, you may be given a window to use. So if you are given a window to use, so if you ever see some numbers on your screen or on your problem that say something like graph using the window, and then you see like -5, +7, -3, +20, for example. I'm making up numbers. But if you ever see anything like that, then what it's telling you is they want you to use these values for your window that I have here. So in order, this is my X minimum, my X maximum, my Y minimum, my Y maximum. Those are what's going to adjust my window. So X minimum controls this left-hand part of the negative part of my X-axis. The X maximum would control out here on the right-hand side of my X-axis. Y minimum would control down here, and Y maximum would control up there. So I can adjust this however I want. So instead of stopping at -10, I can have my window stop at -5. Instead of going out to +10, I can have it stop at 7. Instead of going down to -10, I can have it stop at -3, and instead of stopping up here at +10, I can have it stop up here at 20. So I can change those manually. I'm going to erase this. We've got those 4 numbers there if we needed them. And so what I can do is in my window here, I can manually fix those. And so X minimum, I would type in negative. Do not use a subtraction button if you're trying to type in something that's negative. So use your negative button down here. So -5 would be my X minimum. My X maximum would be +7, like I said. And then your scale, I would not encourage you to switch with your to mess with your scale too much. The scale just says that each one of these tick marks that I have represent 1 unit on the x-axis. I could have each one of them, if I was looking at something where I needed to go way out in my window, I could change this to where every one of my tick marks represented 10 units. So I don't ever mess with the scale unless I just absolutely have to. And then down here, Y minimum, we could go -3. And Y maximum, like I said, we could go +20. And then again, there's your scale. I would leave that at 1. And do not worry about resolution or delta X or just change in X. Don't worry about any of these things down here. It's just these 4 values that you may have to adjust. X min, X max, Y min, Y max. So now when I come back in here and I hit graph, and you'll notice my window is going to look very different. Now I'm not saying that this window made my graph look better. I just wanted you to get used to seeing how this would change your window. So stops at -5, stops at -3 for my Y, goes out to +7, goes up to +20. And again, I can adjust this however I need to. So there are going to be some times where you are going to have to adjust this window quite a bit in order to see something that you're trying to see on your graph, or if you're trying to find a point of intersection or some zeros or something, and you'll see some videos over some of that. So main thing was point that out to you. So now if I go zoom 6, that will take me back to my standard window. And in this question, it's just asking us for the domain and the range of this graph. So remember that domain, we are looking at our horizontal axis. So we're looking at our x values in terms of my domain. So my domain for this function here, which this function is just a polynomial because I just have powers of x, so the 2x to the third minus 4x to the second plus 5x minus 3. So my x values are just being raised to powers. Well, I can raise any number to a power. I mean, I can raise a negative number to a power. I can raise a fraction to a power. I can raise a decimal to a power. I can raise an irrational like pi or something like that to a power. So in terms of my domain, I don't have any limitations for what x could be because I can raise anything to a power. Any real number to a power. So my domain would be all real numbers, which if we use our interval notation would be from -infinity to +infinity. Now, if you can't get that just from looking at your formula, you could also look at your function and notice that in terms of x values, if I change my window, this graph continues to get larger, continues to increase in the right-hand direction, and it continues to get wider, and it continues to increase in this direction as well, continues to get wider. I mean, there's no holes in this graph, nothing that's going to cause me any issues because of what I have over here. But again, if I extended my window in either direction, I would still get a graph. If I were to trace this graph, I would still get a graph no matter how far I came out on the left-hand direction. So all the way down to -infinity, I'm going to be able to find some of my graphs sitting down here. And if I went all the way out to the right to +infinity, I would still have y values. They'd be pretty large y values because my graph is getting larger, but it would go in both directions. along the x-axis. And in terms of my range, if I'm looking vertically, if I'm looking up and down for my y values, then if I started tracing this graph goes all the way down to negative infinity. And if I continue up my graph, it goes all the way up to positive infinity as well. So it goes from negative infinity up all the way to positive infinity in this case. So that would be the range of my graph as well, would be from negative infinity to positive infinity. So you are going to have some questions where it's going to ask you for domain and range, and you want to graph that function on your calculator, and from there determine what the domain and range is respectively. I want to look at a few examples just to help you, one, with the calculator and graphing, and two, just to give you an idea of the different kinds of functions that you're going to see as well. So let's take a look at, I have three more examples that I want to work with you here in this video. So let's go back and let's look at the bottom one there. So it says find the domain and range of f of x or y equal to negative x to the second plus 5. So if your first term has a negative coefficient, you want to read that as negative x squared, which tells me that I want to use that negative button instead of that minus button. So it's one reason why I wanted to work this example, is that when I come back in here to my y equals and I clear this out, I want to type in negative x squared. That's the only time you're going to use a negative button, is if that first term or that coefficient that you have there is negative. So it's going to be negative x raised to the second power, and again, you can either hit raised to the second or use your nice squared button there. So negative x squared plus 5. And we'll graph this in a standard window, and if we need to adjust our window, we will adjust our window from there. So we're already in a standard window, so I'm just going to hit graph. You could hit zoom 6 from here as well. That would also just go graph it for you. So negative x squared plus 5. So I get a parabola. I get that kind of a shape, and that's always what you should get for some kind of x squared function, is either a parabola that opens downward or you may get a parabola that opens upward. So looking at that function there, that window works perfectly for me. And in terms of my domain, well, if I look back at that function, let me update over here, sorry about that. So if I look back at that function where I have negative x squared plus 5, then that's just like my previous example in that that is a polynomial that I'm staring at. Just like that first example was a polynomial, this is a polynomial as well. So if you're ever dealing with a polynomial function, something where you just have terms and you have integer powers of x, then it's safe to assume your domain is going to be all real numbers. But again, if I look at my graph, this graph would continue to get wider. This parabola would continue to open wider. Even if I went all the way down here to negative infinity, this graph would just be getting wider and wider and wider and wider. So my graph does go all the way down to negative infinity. And in this direction, in the positive direction along the x-axis, since I'm looking at domain, this graph would continue to get wider and wider and wider and wider. So because of that, and because this is a smooth curve, there's no holes or breaks or anything like that in it, that's another thing that tells me that the domain of that function is all real numbers. I could trace this entire picture without picking up my cursor or picking up my pen, and if that is the situation, then I know my domain is going to be all real numbers. So there's a few different reasons as to why that domain is all real numbers. So now, if we want to look vertically for the range, and usually you can get domain just from the equation, and you're gonna see that a little bit later on in this chapter. I'm going to talk a little bit more in detail about domain just from looking at equations. But range, it's usually you need the picture to figure out the range. You'd have to really know a lot about these functions to be able to look at that formula and say what the range is. But now if I look vertically up and down this graph and I start tracing this graph, then I notice that it tops out up here at 5. So I could count up 5 units on the y-axis, so 1, 2, 3, 4, 5. So I've got this horizontal line here, y equal to 5. And my graph never goes above that line right there at y equal to 5. But it does go down. So if I go to any of these y values down here, it does continue to go down and go down in this direction as well. So it does continue to go all the way down the y direction in the negative direction. So if I were going to write this from smallest to largest value, and then I would say my domain is from negative infinity all the way up to and tops out up here at positive 5, and it never goes above 5. So my range would be from negative infinity to 5. Now I want to include the 5. And since I want to include the 5, I'm going to use a bracket at that 5 there. That tells me that I have included my 5. Again, we're writing these in interval notation, so we're using brackets around numbers we want to include, and at infinity, either direction, we always use parentheses at infinity in either direction. So be real careful about the brackets and the parentheses because they do make a difference in some situations, so just be careful about that. All right, so again, be careful about the negative button. So if you ever get an error with your calculator, look to see, did you use the negative button? Check your window. That's another thing that will cause you some error issues as well. See if your plot's highlighted. There are some things you can start looking for if you start getting the error message. And if you can't figure out what the error message is, feel free to email me and we'll look at it together. Okay, so let's look at two more examples of looking at some things with your calculator, but also looking at domain and range. I'm going to show you where some different buttons are on your calculator. Excuse me. So this top one here says we want to graph the absolute value of x minus 3, and then from there we want to find the domain and range again. So I just want to show you where the absolute value button is on your calculator, and then again talk about the domain and range. So we're going to go to y equals, and I'm going to get rid of my function there of negative x squared plus 5. So now I want to find the absolute value. So this is one of those things that depending on whether you're in that math print or that classic, it's going to look very different to you, and this is where you would need some parentheses. And I'll throw up here, I'll write it up here what it would look like in classic versus math print. So I want to find the absolute value. And the easiest way I can tell you to go find the absolute value is down here above the 0 is this button that says catalog, which for me is blue. So anything in blue, I want to hit second. So I'm going to hit second, and I'm going to hit 0. And again, I'm already on the y equals, so second and hit 0. And that brings up a catalog list of everything my calculator will do. And it's in alphabetical order, and for me, what's nice about it is that absolute value is the first one in that list. So when I hit enter, since I'm in the math print, it's nice enough to put those vertical bars in there for me. And so if I go back and look at my function, I want this to be the absolute value of x minus 3. So I'm going to make it look identical to what it looks like from what I was given. And then I want to move outside of that absolute value if I needed to, and so I would just move outside that absolute value. So it's going to look identical to what you wanted it to be if you're in that math print. If you happen to be in classic, then what you would get is you would actually get to, they would actually put the ABS and they would open the parentheses for you. And so then you would have to go back and look at your function and say, okay, I want all of x minus 3 to be inside that absolute value. And so because of that, then I would want to put absolute value x minus 3, and then I would have to close my parentheses. So that's how it would look in that classic view. So that's why I said, it looks identical to what it should if you're in that math print. So that is a little bit nicer, but you do have to be careful about your cursor and some different things in that mode. So there's some advantages and disadvantages to both of them. So be very, very careful in terms of which mode or version you're looking at with your software and stuff. All right, so now we know where the absolute value button is on our calculator. And so we can go to a standard window, or we can just hit graph. And we have the absolute value of x minus 3. So again, if I needed to adjust this, so if I needed to see maybe what's happening more out here than I could, absolute values are always going to be v-shapes, kind of like x squareds are always parabolas. Absolute values of something is typically going to be a v-shape for the things we're graphing in this class. Just like with x squared, it may open down as opposed to opening up. This one opens up, but I could get a v that was turned upside down that opened down. So there is my absolute value of x minus 3. So again, Domain you can kind of get from the equation if you know enough about it, and you will as you go a little bit further in this semester. But if I look, this graph goes all the way left-hand side in the negative direction, and then all the way out here on the right-hand side in the positive direction. This graph is a smooth curve. I don't have to pick up my pencil or anything to draw that graph. It's a smooth curve from positive infinity all the way this direction to negative infinity. Don't get confused between domain and range. We're looking at domain, so my graph goes all the way down the x-axis in the negative direction. Looking at my y values, it does follow the x-axis all the way down the negative direction, comes all the way up to where it turns here at 3, and then goes all the way in the positive direction as well. So my domain is negative infinity to positive infinity. Don't get in the habit of choosing or guessing negative infinity to positive infinity. You have a better chance of getting it right if you do guess that, but it depends on the function. We're going to look at one in just a minute where the domain is not all real numbers. All right, now in terms of the range, in terms of my y values, again, I need my graph to figure out my y values. So if I look at my graph here, then I notice that my graph never goes below the x-axis, which on the x-axis, your y values are 0. So my graph never goes down below in the negative direction on the y-axis. It stays at 0, and then it does continue to go up to infinity in this direction, and it continues to go up to infinity in that direction as well. So it goes from 0, and my graph increases, gets larger and larger and larger in both directions. It goes up to infinity in that direction. So my range would be from 0, including 0, because I have a point right there on my graph, all the way up to positive infinity. So my range would be bracket including 0. I'm going to write from smallest to largest, from 0 to infinity would be the range of my function there. All right, let's look at one more example where domain is not all real numbers, and we'll look at a couple different things that would help us figure that out. So, last one here. Want to graph the square root of 5 minus x. So y equal to here. And again, I'm just showing you where a few buttons are on your calculator as well, because these are the kind of functions we're going to be dealing with. We're going to be dealing with absolute value functions. We're going to be dealing with polynomial functions. We're going to be dealing with square root functions. So above x squared, that button we use to square something is your square root symbol. So if I hit second and then I hit the squared button, that will bring up that square root. And again, if I'm in this math print, it's going to put that square root symbol there for me. If you're in the old classic version, it's going to put that SQRT and open your parentheses for you. So again, just be real careful, kind of like the ABS with your open parentheses, very similar. So be careful about that. And so I want the square root of 5 minus x. And so all that needs to be underneath the radical. Or if I was in the other version, it would be square root 5 minus x, and I would close my parentheses. Just, again, depending on which software you're looking at on your calculator and stuff. All right, so square root of 5 minus x. So now we're going to graph that in our standard window. Again, I built a lot of these to work in a standard window. So if I look at the square root of 5 minus x, and I look at this graph, let's talk about a couple of things. So first of all, you'll notice that my graph never goes past that vertical line right there. Never goes past that line, which is x equal to 5. So my graph never goes to the right of 5. So in terms of my domain, it starts at 5, if I'm going to go back in this direction, starts at 5 and goes all the way down my x-axis, and this graph continues all the way down to negative infinity. So it goes from negative infinity up to and including 5. We always read our graphs left to right, but we're just kind of looking at it both directions here. So my domain in this situation would be from negative infinity up to and including 5. So if I were going to look at my equation here, square root of 5 minus x, then there's some things that I know. Well, I'm looking at the square root of something. So I know in terms of real numbers, which is what we're looking at with domain and range, we're looking at real numbers. I know I can't take the square root of a negative number. So I would have to think about the fact that I would need 5 minus x to not be negative. And if I don't want it to be negative, I'd want it to be greater than or equal to 0. And then if you remember some of your basic kind of algebra rules, I would need to subtract 5 on both sides. And that would give me that negative x is greater than or equal to negative 5. And then if I divided both sides by negative 1, that would switch my inequality around since I divided by a negative value. And that would give me x is less than or equal to 5, which is what I wrote over here from looking at my picture of negative infinity to 5. So I'm not saying that you have to know how to do it algebraically, because you're going to have your picture for the most part to help you with this, but I wanted you to see the correlation between what I saw on my graph and the fact that it didn't go past 5, and then if I think about how I would find the domain of that algebraically, just thinking about the fact that 5 minus x can't be negative, which means it's got to be greater than or equal to 0, and just going through and solving. And then if I wanted to look at my range, so I'm going to erase my work right there. So now if I wanted to look at the range of this function, so I want to look at my y values, then again I would need my picture of my graph to help me find range. Then again, you notice that it never goes below the x-axis. My graph never goes below this horizontal line there, which is where y is equal to 0, or on the x-axis. So, but it does continue to get bigger and bigger and bigger and bigger and bigger. Now, it looks like it's flattening out, but it's not flattening out. It does continue to get a little bit bigger, a little bit bigger, a little bit bigger. If I came way down here, my graph would actually be up here if I continued to draw that same kind of shape of my graph. So this does continue to grow larger up my y-axis. So it starts at 0, and it does continue to get larger and larger and larger. So my y values continue to increase all the way to infinity here if I'm looking at this in terms of the direction that my graph is going. So it goes from 0 up to infinity. And again, I'm just trying to figure out domain and range. We're going to talk about increasing and decreasing in a next video, but that's a little bit different kind of concept. I'm just looking at see where what my graph is doing in terms of, is it going to positive infinity on my y-axis? Is it going down to negative infinity on my y-axis? Does it have a point where it stops and doesn't go below? I'm just looking at those kinds of things when I'm trying to determine range and domain as well. So wanted to give you a little bit more of a background with your calculator with this video in terms of graphing, in terms of the y equals. You have the other couple of videos that are not me but someone else explaining just kind of the basics and the buttons that you have on your calculator. And I hope these 4 examples have helped you kind of get a little bit more comfortable with your calculator. There are some tutorials on my MathLab. On the tab on the left-hand side, you can find those there. If you're needing some more help under e-text and other helpful resources, you'll find a couple of tabs there. There are some more graphing calculator videos if you need some help with that. And if you're really struggling with your calculator and just can't seem to get comfortable with it, then that's when you need to contact me and set up an appointment, probably in person or maybe through the Collaborate on Blackboard, to log in and let us discuss and see if we can get you more comfortable with the calculator.